Did anyone have a crack at the test at all? Anybody have a go at any of those tests? Just enough chance that anyone had any questions about it. Oh, you keep tapping away at that, Ollie, while we go through the next topic. Just have a look here for a second. Oh yeah, a couple of people we got. Nathan and Ray have both had a crack at all the tests. Ray's ahead because he's 100% on all of them. Nathan needs to have another crack at one of them. Well done, gentlemen. I greatly appreciate that. Certainly makes my life easier when everybody is up to date, so that is very good. Okay, let's continue with recessed lighting. Okay, so recessed lighting. Now this is obviously, it does not refer to a specific type of lighting like we've just been going through, the LEDs, fluorescence, discharge lighting, etc. This is to do with a specific installation technique as opposed to a specific type of lighting. And the reason that this is important is because there are some specific rules and practices that we need to follow when we're doing recessed lighting. If it's not obvious what recessed lighting is, we're talking about stuff that's mounted in the ceiling, so your downlight type thing. A traditional incandescent fitting, for example, like the ones we've used on our projects, they're surface mount on the ceiling, so the lamp itself will sit below the ceiling. With a recessed light, obviously the fitting itself is recessed into the ceiling space, and so the lamp is in the ceiling space, and that carries some hazards with it, primarily to do with heat and dissipation of heat that we need to be aware of and think about when we're installing recessed lighting. So let's have a look. So our first slide here is just some pictures of what we're talking about, right? So the common feature here is that we've got, the lights are recessed into the ceiling space as I just mentioned. Increasingly common, right? The surface mount light fittings are not particularly common anymore. The standard for household these days is going to be recessed downlights. This is what they look like here. A recessed light or downlight is a light fixture that is installed into a hollow opening in a ceiling. There are three parts to a recessed lighting fixture: housing, trim, and lamp. The trim is the visible portion of the light, so that's the bit that you can see from the bottom. Excuse me. It is the insert that is seen when looking up into the fixture, and also includes the thin lining around the edge of the light. So the insert, yeah, the insert is the part inside. So if I take the bulb out, that's the bit that I can see up inside the light fitting. The housing is the fixture itself that is installed inside the ceiling and contains the lamp holder. There are many different types of lamps that can be inserted into recessed light fittings. However, which type needs consideration due to the dangers of the heat generated. So again, we're primarily talking about heat here. So most of what we're going to talk about now is centered around legislative requirements. So we have a reference to legislation here, 4.5.1 of ASNZS 3000. Unless stated otherwise, all of these references will be to do with ASNZS 3000. So 4.5.1.1 says all lamp holders shall be located to be adequately protected against damage that might reasonably be expected. In order to protect against inadvertent contact with live parts, Low voltage lamp holders shall be located to minimize the risk of direct contact with live parts of a lamp holder when the lamp is removed. And mechanical damage to the lamp or lamp holder. These requirements may be satisfied by installation not less than 1.8 meters above the ground floor or platform, or provision of a suitable guard for the lamp and its lamp holder, or the lamp holder is incorporated in a luminaire. A pendant lamp holder should not be exposed to the effects of significant movement of air, for example, outdoors, or exposed to the operation of fans, etc. So it's pretty broad. It's just saying that we need to protect the lamp holder, or protect people from contact with live parts on a lamp holder, which that's pretty standard, right? There's nothing controversial there. And we need to protect our lamp holders against damage, mechanical damage. It outlines a couple of methods that we do that. So if we install it no less than 1.8 meters above the ground, then that is deemed to comply with the requirement to protect from mechanical damage. Or we could place a guard around it. (4.5.1.2) Edison screw lamp holders. We should all know this one by now. Every low voltage Edison screw lamp holder shall be connected to the supply so that where a neutral conductor is required, it shall be connected to the outer contact. Right, so that's just protection. If you don't remember that, if I go and grab that lamp that I'm not, and I potentially contact the screw thread on the outside of the lamp, then I'm not going to get a shock. That screw thread being one of the terminals. So the outer screw thread must always be the neutral. The inner terminal will be the phase. Festoon lighting, we looked that up the other day. So this is hanging lighting, where the lamps are physically chained or hung on a cable, and then we hang that cable, like Christmas lighting type thing. 4.5.1.3, which we did look at the other day, says that festoon lighting shall be located and supported so that no lamp will be within 0.15 meters of flammable materials or structural metalwork, or arm's reach of the ground or any other place on which a person is likely to stand. Arm's reach is generally defined as 2.4 meters. I think we talked about this the other day. So that's about the height that I can reach up into the sky from standing flat-footed on the ground. And it is roughly the equivalent of a standard ceiling height in a house. So it has to be, festoon lighting should be installed above normal ceiling height and not within 15 centimeters of flammable material or structural metalwork. Exception, festoon lighting may be within arm's reach where installed immediately below a ceiling. So if I was hanging it off the ceiling being the arm's reach, then that's okay. 4.5.2, lamps and luminaires. General lamps, luminaires, and their associated ancillary gear shall be so installed as not to cause undue temperature rise, ignition, or deterioration of the materials, A, on which they are mounted, or B, that they illuminate. Luminaires shall be suitable for the highest temperatures to which they are likely to be subjected by external influences and be installed in accordance with the manufacturer's instructions, taking account of the highest rating of lamp to be used. So all that's saying is that we need to take care when we install lights that that the light itself is not going to damage anything around it, whether that's the surface upon which it is mounted, either usually a ceiling, could be a wall, and in the case of a wall-mounted light fitting, which you do see, or the material that they're illuminating. So I guess that's just saying, you know, I don't want to install, if I had a hanging chandelier or something, I don't want to install it so it would be so the heat coming off those lamps would harm anything that was below that, I guess. Lamps near flammable materials, 4.5.2.2. Where lamps are located near flammable materials, A, lamps shall be suitably shielded by a shade, reflector guard, or enclosure to prevent contact with the materials. Lamps such as spotlights that generate heat on the illuminated surface shall be separated by such a distance that the material will not attain excessive temperature. Where information is not otherwise provided with products, the minimum separation distances given table 4.2 shall be used. Flammable shades shall not be installed where they are liable to come into contact with any lamp. So if I'm going to put the lamp near something flammable, I need to have some sort of shield or guard to prevent contact with that material. And with spotlights where there might be heat generated by the lamp other than by touching, by the lamp shining on a surface, we need to maintain minimum clearance distances. This might be spotlight type lamps like you would see like in an art gallery or something, where the spotlight is actually illuminating directly on a painting or something like that. I mean, it's not a great example because we're not all running around installing lights in art galleries, but same sort of idea, that if that spotlight is focused on and close enough to something that it might cause damage by heat, then we need to make sure that we're observing those minimum distances. And it tells us here that the minimum distances are contained within table 4.2. I'm not going to go and look that up, but that's where you would find it if you needed to do so. Oh, well, there it is, very next slide. So depending on the rating of the lamp, so if it's less than 100 watts, the minimum distance is 0.6 meters, 600 mils, which is not too big. Reasonable distance. If it's between 100 and 300, then it's a meter. Over 300 watts, 1.8 meters. That's my height. So a lamp over 300 watts must be at least 6 feet, 1.8 meters away from the illuminated surface. 4.5.2.3, recessed luminaires. Recessed luminaires and their auxiliary equipment. So the auxiliary equipment in this case might be a transformer. That's probably what we're talking about there. So if I have a downlight, a 12-volt downlight that has a transformer that comes with it to change the 230-volt supply down to 12 volts for my lamp, that is what constitutes auxiliary equipment. So they shall be installed in a manner designed to prevent excessive temperature rise of the luminaire and auxiliary equipment and the risk of fire from ignition of combustible materials. So all those previous clauses that we looked at, most of those will be satisfied normally just by normal installation processes, right? I'm not normally installing lamps that are, or lights that are going to be so close to something that they cause a great deal of heat or catch fire. I'm not normally installing lamps that are going to be so big and output so much heat that they're going to affect the lamp holder itself or the surface that it's mounted on, like the ceiling. So all of the stuff prior to this slide, you worry about it in certain situations, but in the normal day-to-day, it's not going to be a big deal. When we start talking about the recessed lights, then that changes a little bit. Because inherently, just by installing them, we're creating this hazard. It is worth noting, actually, let's just take a pause there. It's worth noting that all of this applies to incandescent lights. Whilst the standard itself does not specify incandescent or LED lamps, it's clear that the intention of these clauses is around incandescent lamps, because incandescent lamps, as we know, as we've discussed at length, and as I'm sure all of you have experienced in your personal lives, incandescent lamps are hot. They'll burn you if you touch them. Really hot, right? So if you took an incandescent lamp and buried it under flammable material and left it running, something's going to happen. There's a very high chance that it's going to catch fire. So when we install an incandescent lamp recessed into a ceiling space, particularly thinking about things like thermal insulation that's up there, the building materials that are now completely surrounding my lamp, the jib and the timber in the ceiling and stuff, that's what we're talking about. So it wouldn't be a huge stretch for us to say that once we start talking about LED fittings, a lot of this stuff doesn't apply. Now, currently, the legislation, as I'm reading it here, and as I understand it in general, does not differentiate between an LED and an incandescent recessed fitting. But we understand clearly the LED is not going to emit anything like the same amount of heat. And therefore, these considerations are less important. So two things there. One is that, well, if it doesn't differentiate between LED and incandescent, then the rules as they are written still apply to LEDs. But the spirit of that law is clearly intended to be about incandescent lamps. So it's less of a concern if we're doing LEDs, although it's not an excuse to ignore the law. I suspect at some point in the future it would likely be amended to take that into account. And saying that, LED lamps do emit some heat. Not usually the bulb themselves, or not usually the LEDs themselves, but the control gear, the driver and stuff, will emit a bit of heat. Still not as much as an incandescent. And I suspect, given the number of times I've already told you, that we will likely see over the next few years incandescents and really most other types of lighting slowly phased out, and LEDs will take over. That rules like this will be rewritten to take that into account. It almost surprises me actually that they don't already have a differentiation between rules that apply to incandescents and rules that apply to LEDs. But the reality is, all of these rules are about the installation of new new incandescent downlight fittings, which no one should be doing that even now. The fact that incandescent fittings still exist is irrelevant in terms of new installations. I think I said to you guys the other day, if you find yourself in new incandescent downlights, stop, slap yourself, and ask why you're doing that. It's unnecessary. Okay, back to the slideshow. These requirements shall be satisfied. What requirements are we talking about? Excessive temperature around our recessed luminaires. These requirements shall be satisfied by one of the following compliance methods. Installation of a luminaire designed and certified by the manufacturer as being suitable for operation A, in contact with combustible material, or B, in contact with or closely or enclosed covered by thermal insulation material. 2, the installation of a luminaire in combination with a barrier tested and classified in compliance with AS/NZS 5110 as being suitable for the installation conditions. So, right, what are these two slides saying? The first one is saying that we have to take into account the risk or hazard associated with the heat generated by a recessed luminaire. Again, let's be clear, we're talking about incandescents here. So, there is heat being produced, we need to do something about it. The second slide here, this one we're looking at now, tells us the ways that we can comply with those requirements. The requirement that we need to deal with that heat, or need to be aware of the heat. What does it actually say specifically? Let me go back for a second. Yeah, they must be designed and installed in a manner to prevent excessive temperature or risk of fire. Yeah, that makes sense. So how do we do that? Well, this tells us that if we use a light fitting that is certified to be in contact with combustible material, or certified to be in contact with or covered by thermal insulation, then we're fine. So what that's saying is that provided the light fitting is designed to be in contact or covered with thermal insulation, then I don't have to worry about it. I can just install that anywhere I like, if the light fitting itself has that certification. So that's our easiest way to deal with this risk, right? Is that, well, I just don't deal with the risk. I just buy a fitting that is designed to take care of that risk for me, and then I don't need to worry about it. So that would be the first place that I would go if I was doing this. I'm just going to get fittings that are certified to be placed underneath thermal insulation, and then I can just drill a hole, stick it in, put the thermal insulation over the top. Don't worry about it. Now the second way here, presumably, if my fitting does not meet those requirements, my fitting itself is not certified to be in contact with flammable material or covered with thermal insulation, then I should install the light fitting with a barrier, which has been tested and classified in accordance with this standard here. That appears to me to be significantly more hassle. I can either just buy a fitting that's suitable, or if I buy a fitting that's unsuitable, then I'm going to have to go and buy an additional cover or guard that that has also been tested and certified. So either way, I'm going to have to get something that's tested and certified. So I might as well just go for the light fitting, right? Does that make sense to everybody so far? Silence. All I just need just a thumbs up from someone. Or somebody to go, what? No, none of this makes sense. You're talking rubbish. I'm kind of disappointed, actually. None of you ever tell me I'm talking rubbish. I'm constantly talking rubbish. Grow some nuts. Okay, let's continue then. Yeah, I'm talking rubbish. Thank you, Tanner. Well, I mean, I said grow some nuts and tell me I'm talking rubbish, but now you're only saying it because I told you to, which just proves you don't have any nuts. Just continue to do whatever I say. I'm still okay. Yeah, no, I am talking rubbish. Yeah, fair enough. All right, I'll give you that one. Where are we? Okay, the third way that I could satisfy that requirement to make sure that my recessed light fitting is not going to overheat is to install the luminaire with separation from thermal insulating materials and combustible building elements and loose cut combustible materials, not less than the minimum clearance specified by the manufacturer of that luminaire, which may require a barrier or a guard constructed of fire-resistant materials, or the default clearances as specified in figure 4.7, which may require a barrier or guard constructed of fire-resistant materials. Okay, so far we've got two ways that I can satisfy this requirement to make sure my light fitting is not going to overheat. I can buy a fitting that is constructed not to overheat, that's certified to be used in these circumstances. I can use a regular fitting, but I can put a guard around it that is certified. Or the third way, I can make sure that any combustible material and thermal insulation are moved away from the fitting itself to a set of minimum distances, either the minimum distance specified by the manufacturer, or failing that, distances specified in figure 4.7. So this is not an not an ideal option, because it's going to mean that I'm going to have to move the insulation. If I cut a hole for my downlight and I put the downlight in, then I have to move my thermal insulation out of the way, which is not great. The homeowner is probably not going to be happy with you, because you're going to leave spots in their ceiling that have no insulation. And here we have figure 4.7. So this is giving us the minimum distances to combustible building elements or thermal insulation. So that distance C is the distance that my thermal insulation must be away from my luminaire. Side clearance to thermal insulation, 50 millimeters. So not huge. Okay, so I have to make a circle around my light fitting that's 50 millimeters outside my light fitting. My light fitting's this big, and I'm going to have 50 millimeters outside that. The distance A is the clearance above the luminaire, 200 mils. So this would should only really be relevant if we're installing them in the bottom floor of a two-story building, right? Because then we have not a huge distance between the ceiling of the bottom floor and the floor of the one above it. So I need to have at least 200 mils, 20 centimeters. If I was just installing it to a normal ceiling and then the only thing above it is the roof, there should be heaps of clearance. B is the distance from the fitting to combustible building element, which is that drawing there is to represent timber, part of the framing. So that says also 200 millimeters, 20 centimeters. So now I mentioned about installing recessed lighting the other day, and I said that there's a little trick. I explained how you poke a hole in the ceiling and then go up the top and have a look, get your template, blah, blah, blah. That's important. What I was talking about at the time was like, don't try and drill a hole or cut a hole for your downlight into the timber, because it's going to be a nightmare. But this also tells us we shouldn't do that because of the risk with the fire risk of the heat coming off that luminaire. If I installed it right next to the timber, or even if I cut part of the timber out to try and install the luminaire in there, that's bad news, right? That's illegal because it's too close to something that's combustible. Interestingly, it does not mention anything about the ceiling itself, right? Looking here at the ceiling, doesn't consider that a combustible building element like it does with the structural timber. I'll take a risk and ask a question here. Does anyone want to hazard a guess why? And why are we concerned about this bit of timber, but we're not concerned about the ceiling itself? Oh, looks like Jade started typing something, and then know structural damage. What do you mean by structural? Oh, as in that damage to the timber would be more serious than damage to the ceiling. Is that what you're saying? It's a great answer, but you're wrong. Anyone else? It's not a bad answer. It might be true, but that's not what I was thinking of. No, nothing? Well, the answer is, look, the ceiling is going to be made of jib, and jib is not really flammable. It's made of chalk, so it's not going to go up in flames. You'll find it very, very difficult to burn a piece of jib. So when we're talking about flammable building materials, we're not including the jibs. It's the timber up on the ceiling. Also note here that regardless of the presence and distance to building elements and thermal insulation, it mentions that we must have a minimum distance to the transformer. So if it's a 12-volt fitting that has its own transformer, then the transformer should be 50 mils away as well, because that could be damaged by the heat coming off that lamp. Okay, this one's important. Warning signs. Where recessed luminaires are installed in an accessible roof space, so inside a roof space that I can get into, a permanent and legible warning sign shall be installed in the roof space adjacent to the access panel. So wherever we're getting into the ceiling, the manhole, there should be a sign up inside the ceiling next to the manhole. It must be in a position that's visible to a person who's entering into the space, and that sign shall comply with AS/NZS 1319 and contain the words shown in figure 4.8 with a minimum size lettering of 10 millimeters. And here it is here. So that sign should say, warning, recessed lights have been installed in this roof space. To reduce the risk of fire, do not cover the light fittings with thermal insulation or any other material unless in accordance with instructions provided by the light fitting or barrier manufacturer. Now, I think that's interesting and important because I've never seen one of those. I've never seen one of those in a roof, but I've been in dozens of roofs with recessed lights in them. So clearly people don't give a shit about that one. But that's a hazard. That's a hazard for us as electricians, right? Like for two reasons. One, if we install something and we don't put that sign, if somebody else comes along later and monkeys with those fittings and they don't know any better and that causes a fire, then we're partially liable because we're supposed to put that sign there. If you put the sign there and they do it anyway, well, that's on them. But if we don't put the sign there and somebody comes in and puts insulation over those fittings and it causes a fire, we are partially liable for that. And the second reason is, for us as electricians, if we're going into a roof space, we want to see warnings like this, because that tells us, I better not, I better be careful with what I do up here. I don't want to move something so that I end up covering light fittings or something like that. So I would imagine, again, I've never seen one, but I would imagine you'd be able to buy something like that. Most of the time when the standards say that you have to have a sign that says this or that, you can buy those signs at the wholesaler. They supply them. If it's legally mandated that it has looks a certain way or has certain words, then someone will be selling those things. So we should be able to get them. But again, I've never actually seen one. It's still, with or without the sign there, still the best and easiest option for us to protect against the fire risk is to use fittings that are certified to be used under thermal insulation, and then we don't have to worry about it. Then we just do what we like. Are you going to go and find your manhole after this? Are you going to go and see if there's a sign? Do you have downlights in your house? Well, I can tell you that I 100% I know for sure that there is no such sign in my house. And my whole house is downlights, although they are all LED downlights. That's one of the reasons, actually, don't tell my wife, but that's one of the reasons why I wanted to move into this house, is because it's LEDs. The whole house is LEDs. There's not a single incandescent bulb, and they're not normal fittings with LED bulbs screwed in. They're proper LED, proper LED fittings, and I love them very much. So we don't have that same heat issue. But again, this doesn't actually say, oh, you only have to do this if they're incandescent downlights. It just says if there's downlights, you should do it. Yeah, I doubt you'll find it on the Bunnings website, Ray. This would be something that's fairly specialized. So you probably find it at an electrical wholesaler like J.A. Russell's or Active Electrical or something like that. Okay. 4.5.2.3.3, following precautions should be undertaken for the installation of recessed downlights. A, the heat generated from lamps should be dissipated in order to prevent over-temperature damage to the luminaire or adjacent materials. Cooling air circulation through or around the equipment is a requirement for the typical range of downlights. There's a couple of standards listed there, and they detail the test method and maximum surface temperatures permitted for recessed luminaires. The maximum temperature of the adjacent materials is to be no more than 90 degrees. Okay, so we're not going to go into those standards. We don't need to do that now. What we do need to understand is that those two standards there tell us how we test the temperature and what the maximum temperature is allowed to be for a recessed luminaire. So that gives us a methodology by which I could test how much heat is coming off those lights and what the maximum temperature is allowed to be. Oh, see, we've got a comment from Bailey here. Don't tell my wife. Yeah, you're not supposed to tell my wife stuff like that, because if she found out that, well, she thinks that we moved here because I like the house. If she found out that we moved here because I like the lights, she'd think I'm a moron. She'd think I'm a moron even more than she already does. I'm talking rubbish. Okay. Well, only because, yeah, all right. Let's move on then. Okay, so additional methods to, hang on, where are we? Additional precautions for the installation of recessed luminaires. In the case of a suitably designed and certified luminaire, compliance method 4.5.2.3.1i. So that was where we were using a luminaire that's allowed to be covered by thermal insulation. So if I am doing that, the manufacturer's instructions may restrict installation, including warnings such as covering with insulation or the following symbol, meaning do not cover. So if I have a suitably designed fitting, I need to check that it doesn't have this label on here. That picture there means do not cover. For typical fittings, so just the ordinary bog standard downlight off the shelf, the installation method will be to provide barriers or clearances. So it's saying that, yeah, okay, maybe I've got a fitting that can be covered with insulation, but in most cases we won't. So then we're either going to be putting a barrier in or using the clearance method, which is maintaining those specified distances as we saw in that diagram. So any unmarked fitting shall be treated as do not cover. So if there's no markings on it, nothing to say whether it's certified or not, then we have to assume that it's not allowed to be covered. Okay. Under National Building Code requirements, so this is building code, not electrical legislation. Bulk thermal insulation, that just means pink bats or whatever is in the ceiling to provide insulation, is prevalent in modern building construction within roofs, ceilings, walls, and floors, depending on the type of building and its climate zone. So it's just saying, okay, so we are going to see thermal insulation. It does exist. In fact, should be in most buildings. Bulk thermal insulation may also be retrofitted, added, or altered, in which case precautions will need to be applied by the insulation installer where recessed downlights are present, or the luminaire installer where insulation is present. So that's saying that if I go and install lights into a ceiling that has no insulation and somebody comes and does insulation afterwards, they need to make sure that they take precautions. If I'm putting the luminaires into a ceiling that already has insulation, I'm the one who's responsible. So it's just delineating who's responsible for those things. AS 3999 and NZS 4246 include instructions for installation installers in relation to clearances from recessed downlights and other types of electrical equipment that may be adversely affected by lack of cooling air circulation. So there's a couple of standards there that apply to specifically to people who install insulation that they need to comply with regard to putting in insulation into a ceiling space that already has recessed light fittings in it. I've seen this once. I owned a house a few years ago in which had very poor insulation. So I hired a company, and they came from I think they came from Napier. They do trips up and down the island, and they used a wool insulation, which I liked because I'm very, very sensitive to fiberglass insulation. I don't know if all of you have come across this, but pink bats or any other type of fiberglass insulation, when it's disturbed, little bits of the glass fiber go into the air and they get on your skin and they get into your skin, and it's bloody horrible. It's a miserable experience. And I find that I'm affected by that more than most, I think. So I hate it. So when I found out that I could get insulation installed that was not fiberglass, I was like, hell yeah, I want that stuff. So I got this company, and they were pretty cheap to use wool. So it's like a wool fiber, and they use a big blower and they blow it up into the ceiling. So when they and re-insulated my ceiling, they just had buckets, just like $2 Bunnings buckets, and one of the guys went up in the ceiling and he just put a bucket over every light fitting, and then they sprayed the insulation in, which I'm still a little bit unsure whether that was legal or not. In regards to using that bucket as a barrier, like it said, there was that one method it talks about here that says we can use a barrier. around our light fitting, it says it has to be a certified barrier. So a plastic bucket from the hardware shop is not a certified barrier. However, if we think about it from the point of view of providing clearance, as in, what was it, 50 mils around the outside of the fitting, 200 mils above, so on and so forth. Well, actually, then the bucket is not a barrier. It's just there to maintain that clearance, right? So as they spray the insulation in, it can't get into the bucket, and therefore we're adequately maintaining a 50 mil distance, clear distance around the outside of the light. I tend to lean towards it's probably a barrier and it's probably uncertified, so shouldn't be done, because I think the clearance method requires that there's nothing in the way, right? So we have clearance around the fitting, but then there's free passage of air where the bucket is going to restrict that. So the bucket would be a barrier rather than something that maintains the clearance. I mean, it's neither here nor there. I was kind of surprised, to be honest, that the insulation guys even did that. Because if I'm honest, in the trade world, people who do insulation for a living are perhaps not considered the brightest in the world. It's a pretty miserable job. So there you go. The presence of bulk thermal insulation. So again, this is talking about pig bats or whatever, particularly over the rear of a ceiling mounted downlight, can readily impair cooling air circulation unless the luminaire manufacturer specifies otherwise. Compliance method, blah, 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 blah. That means they're using a fitting that's rated to be under insulation. Or the barrier is classified to permit insulation coverage. The space above the luminaire, shown as dimension A on figure 4.7, that was the 200 mils, shall remain clear, and a warning sign as shown in figure 4.8 shall be installed. Yeah, so we need to maintain that clear space and have a warning sign. Okay. Combustible materials should be prevented from being in close proximity or contacting hot surfaces of the luminaires. This includes structural timber, which may be affected by pyrolysis, which over a long exposure can result in increased susceptibility to ignition. Where extraneous materials such as leaves, vermin debris, or combustible materials stored in a roof space are present in proximity to the downlight, the precautions shall include the use of a suitably designed and certified luminaire or a barrier. Okay, so we must keep any combustible material away from the luminaire. Talking about pyrolysis and the structural timber, I believe that's to do with the process by which that heat over time can dry that timber out and make it visible, even though it may not be the actual light itself that sets it on fire. Where there's extraneous material, leaves, vermin, debris, or combustible materials, then essentially it's saying we use either a suitably designed luminaire or a barrier. So it's saying that we should treat those things as the same as we would treat any other material, structural timber, thermal insulation, or whatever in the ceiling. So just anything. I don't think vermin debris is talking about rat traps necessarily, Jade. I think it's probably talking about like actual dead things. Most of the time, might surprise you, but most of the time if you go in a ceiling space or under a floor, you're likely to find something dead in there. Dead birds are pretty common. Dead mice and rats are pretty common. Such is life. You'll all find out when you're apprentices. That'll be your job for the first year or so. So you got to crawl into every ceiling and under every floor You get used to seeing dead rat skeletons and stuff. Unless the auxiliary equipment instructions permit otherwise, any auxiliary equipment operating at a high temperature shall be installed above any insulation as illustrated in figure 4.7. Okay, that's very simple. Auxiliary equipment, again, that refers to the transformer for our lower voltage lights, and it says it should be installed above any insulation. Well, that's easy. That means I don't put the transformer under the insulation. I put it on top of the insulation. That shouldn't affect me. It's easy to do because it's got a lead on it. It just sits there. I can move it around. So I just don't put that under the insulation. No problem there. That doesn't affect me at all. Okay, additional requirements for New Zealand only. Only recessed luminaires of class ICF, IC, CA80 or CA135, which are compliant with ASNZS 60598.2.2, including New Zealand only Amendment A, shall be installed in residential buildings. So that's obviously talking about specific classes of downlights. And we must only use those. That should be an easy requirement to comply with, because if we go and buy something off the shelf, nobody in New Zealand should be selling you fittings that don't comply. So you should be able to just buy anything you buy off the shelf should meet those requirements. If the recessed luminaire is supplied with a detachable barrier, the complete luminaire, including its barrier, shall be installed. So if you buy a fitting and it comes with a barrier, and maybe you take the barrier off to do the wiring or something, this is telling us that you have to put the barrier on. You can't leave it out. If it's supplied with it, you must use it. All classes of recessed luminaire shall be spaced from other building elements as given in the luminaire manufacturer's installation instructions. If no instructions are available, default clearances shown in figure 4.9 shall apply, and a fixed guard constructed of rigid fire-resistant material may be required. We got 4.9. No, we do not. So this just means there's an additional requirement for New Zealand that if we don't have any instructions around the clearances around the fitting, then we have to use clearances shown in figure 4.9 of ASNZS 3000, although we don't need that. We don't need to look at that now. Just need to be aware that that is the case. And that's it. That's that slideshow over. Boom, another one done. How about that? Questions? I told you these ones would be pretty easy. I feel like they're pretty straightforward. LEDs and recessed lighting. I know that recessed lighting one is it's a little bit dense in the sense there's a lot of legislation stuff, but once you think about it, it's all pretty common sense. There's nothing in there that's really complicated. If you want to boil it right down to something easy, don't cover the lights with insulation, and make sure you put a sign in near the manhole. That's it really. If you did those two things, then you're 99% of cases you're going to comply with everything that we just read. Don't cover the fittings, put up a sign. Questions? Go, questions. Nothing at all? Really nothing? Okay, nothing. All right. Well, that's us for today. Now, one last thing to discuss. So, the chances of me being at work tomorrow are slim to none. In fact, I've already made the call. I'm not going to go to work tomorrow. I'm not going to go at all this week. I had a COVID test yesterday. Actually, I got a text at lunchtime and it said negative. So I haven't got the COVID. So none of you have to worry about that. But I'm still, I don't want to turn up to work and give other people sickness. I certainly don't want to turn up to work sounding and looking like this, because everyone will treat me like I've got AIDS. So I'm going to stay home. So tomorrow then, here is my proposal. I'm interested to hear your thoughts. Tomorrow we stay home, we do online classes again. We'll do another couple of topics. It'll mean that we obviously miss the interesting point, Bailey. That's a very well constructed argument. I'll come back to that in a second. I propose that we do online classes tomorrow. We'll smash out another couple of topics. I won't make the tests for those due this week. I'll make them due next week, so you're not having to do like 7 tests in 1 week. We'll miss tomorrow's practical, but it'll mean we'll do 2 days practical next week instead. So instead of doing 2 days of theory, 1 day practical next week, we'll do 3 days theory this week, 2 days practical next week, 1 day theory. How does that sound to everybody? Jade and Raymond are happy. Max Barkley is happy. Everyone's happy. Okay. Oh, that kind of surprises me. I thought everyone would be like, "No, I want to do my practicals," but I think that's the best option. So I appreciate everyone is on board with that one. The topic for tomorrow, Ray, we will do. I think we've finished lights now. Just give me a second. I'm pretty sure we're on to transformers. I think it's single phase and 3-phase transformers. Yes. Single phase transformers, 3-phase transformers. Those will be the 2 topics that we'll cover tomorrow. But as I say, I'll put the due date for those 2 tests as the end of next week, in addition to whatever topics we cover on Monday. So although we'll do those topics this week, we need not do those tests. Of course you can if you want to, there's no issue there, but I'm not going to force you to do 7 in a week. We've already got 5 to do for this week. Okay. Oh, that works for me then. So what I'll do is I'll set another Teams class up for tomorrow and send everybody the link for that again. I think that's it. Is there anything else that I have forgotten? Anything anybody's concerned about? Oh, there will be MMA. Matt's going to take MMA on Thursday. I've got all my jiu-jitsu and MMA classes covered for the week. Yeah, I don't need to be turning up at the gym giving everybody my disease either. Oh, right, yeah, going back to Bailey's point there. This is not about me having balls, Bailey. It's about being a good workmate and just a good neighbor to people around me. I don't need to get everybody else ill. Somebody else has already done this to me, whoever it was. So I certainly don't want to be doing it to anybody else. I'm just being considerate to my friends and neighbors, Bailey, in this post-COVID world. Okay, all right. Sounds like we're all happy. So yeah, there's obviously those tests to do. The topics that we covered today are all unlocked. So you're more than welcome to jump into those. I'll be around for the afternoon, so feel free to text, call, message me if you need help with anything. I mean, try your best not to come up with brain dead questions. It tends to be that when people do ask me stuff, they're generally pretty dumb, but okay. Yeah, if you have any issues, get in touch. Otherwise, we'll see you here again tomorrow at 8:30. Good job, team. I appreciate you. I know it's hard to sit here and concentrate. You're doing great. Well done. Bye. 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 Miss you. Bye.